Good day, everyone. This is Orekoya Fumi Olusegun on Physics Mathematics Fundamentals on YouTube. Physics Mathematics Fundamentals on YouTube. Today, we are taking a topic on electricity, and that topic is going to cover electric charges. And if you have time, we are also going to discuss, the movement of a charge under the influence of electric field. Now, we are starting with the concept of charge. What is a charge? A charge is defined as the property of matter that determines how it will behave when placed in an electromagnetic field. Now, let me write this definition again. It is the property. It is the property of matter that determines how it will behave under the influence of magnetic field. Now, electromagnetic field is formed by the interaction. Electromagnetic field is formed by interaction of electric field and magnetic field. So that's the meaning of electromagnetic field, the combination of electric and magnetic field. So when charge Q is placed under this particular electromagnetic field, it will behave in somehow due to the charge on Q. Now, I want to introduce the concept of a test charge Q, this Q that we have here. Now, let me first of all describe the test charge. A test charge is used to determine the behavior of the line of force surrounding another charge. What am I trying to say is this: when we place a test charge close to another charge, is this test charge going to be attracted or be repulsed by the other, or be repelled, by the other charge? Now, the test charge, conventionally, the test charge is normally taken as carrying a positive charge. So now, the line of force that comes from this test charge describe what is called the electric field. Now, if you place another charge, let's say this charge Q here, this charge Q may be positive or negative depending on which of the charge we want to use here. So we want to see how this test charge will behave when it is placed close to this charge Q. Now, if charge Q, let's say, is negative, from the principle of the fundamental principle of electric charge, the fundamental principle of electricity state that light charges repel, yes, and unlike charges attract. Now, what this one is saying is this: if you have charge Q and you have another charge Q and they carry like charges, let's say minus minus, the line of force for the negative is inward towards that charge. So for this one too is inward towards this, so it is inward towards this place. Because the line of force happen to be away, in each case there will be a repulsion. Between these two charges. According to the fundamental law of electricity, we talk about light charges repelling. So if this charge Q is also plus, and this one we also have plus. For the positive charges, the line of force happen to be outward. So if you move these two charges close to each other, because the line of force are against each other, there will be a repulsion. The line of force will be repelling from each of the charges. So for the like charges now, we have repulsion. Now for the unlike charges, let's put the case of unlike charges now. In this case of unlike charges, if you put charge Q here and another charge Q here, if this particular charge Q is positive and this one is negative, we know that the line of force of this one will be outward and the line of force for this one will be inward. So there will be a kind of attraction between these two charges. So the line of force will be coming from the positive charge and going to the negative charge. So we have something like this as the diagram concerning line of force between two unequal charge. This is negative charge and this is positive charge. So we have something like this. This is a attraction. Now if you take this concept to this particular charge here, you can discover that if this charge is negative, this positive test charge will move towards this negative charge because it's moving towards. That means we indicate the movement like this around it. So this particular field shows that the positive charge is moving towards. That's why this negative charge has the field, radially inward. Now instead of having negative charge, let me say I have a positive charge, and see the test charge is always positive and this positive discharge, and we know that there will be repulsion. That means this particular positive charge will be repelling away from this test charge. That's why the line of force is radially outward from the positive test charge. So I believe that you've learned one or two things pertaining to electric charge. The second charge that we have here that we are testing this test charge on is called source charge. So you can distinguish between a test charge and a source charge. A test charge is used to determine the line of force around a source charge. So thank you. In our subsequent video, I'm going to give other illustrations on the concept of electricity. So this is electricity part 1. Please do not forget to like, share and subscribe to my video. Have a nice day. Bye.